These are the generators that everybody's buying for blackout season, and almost nobody realizes they could put every expensive electronic in their house at risk. Tri-fuel generators, gasoline, propane, natural gas, all in one machine. They've become the hottest segment in the backup power market, and it's easy to see why. When the grid goes down, you want options. You want to hook up to your home's natural gas line and run indefinitely. Keep a propane tank in the garage as a backup and grab gasoline if that's all the station has left. It sounds like the perfect solution. And the manufacturers know you think that. So when you're shopping, they hit you with the one catch they want you to focus on, which is the wattage drop. Every tri-fuel generator tells you right there on the spec sheet that you'll lose power when you switch away from gasoline. 10 to 15% less on propane, another 5 to 10% less on natural gas. A generator rated at 11,000 watts on gasoline delivers roughly 9,000 to 9,500 on natural gas. They disclose it, they explain it. Gasoline packs about 125,000 BTUs per gallon compared to propane's 91,000, and natural gas is even lower. Less energy density means less output. Makes sense? You accept the trade-off? But that's not the catch that should actually worry you. Think about what you're really buying a generator to protect. Not just a laptop, your refrigerator full of groceries, your freezer full of meat you don't want to lose, your home's HVAC system keeping the house livable, your internet and security system so you're not sitting in the dark cut off from everything, medical equipment that someone in your house depends on to breathe or stay stable. That's what's actually on the line, and almost none of it gets protected by the spec everyone shops on. Here's an easier way to picture it. Imagine your home's electrical system expects a steady, consistent supply, the way an engine expects clean fuel. Now imagine that supply is slightly off. Not enough to shut anything down immediately, but enough that it's working harder than it should be every time it runs. Nothing fails today. Nothing fails this week. But run components on that mismatch long enough, and the wear adds up. That's dirty power. And most tri-fuel generators produce more of it than anyone selling you one will tell you. The real catch is buried deeper, and most buyers never find it until something breaks. It's called THD, Total Harmonic Distortion, and it determines whether the electricity coming out of your generator is actually a match for the devices you're trying to protect. Here's how it works. Electricity from your wall outlet flows in a smooth, predictable wave pattern called a sine wave. Your laptop expects it, your furnace control board expects it, your CPAP machine expects it. When a generator produces power, the goal is to replicate that same smooth wave. And THD, Total Harmonic Distortion, measures how far the generator's output deviates from that ideal. It is expressed as a percent, where the lower the number, the cleaner the power. The three numbers worth remembering. Under 3% is considered excellent, safe for essentially anything you would plug in. Under 5% is generally workable for most consumer electronics. Above 10% is where electricians and equipment manufacturers start flagging real concern for sensitive gear. Everything else is just proof of where a given generator lands on that scale. Here's where it gets worse. Most tri-fuel generators on the market are conventional generators, not inverter generators. Conventional generators produce electricity by spinning an alternator at a fixed 3,600 RPM. And every fluctuation, every load change, every hiccup in engine speed shows up directly in the electrical output. The result is what the industry calls dirty power. And once you start checking, it's everywhere. We looked at nearly every major tri-fuel generator on the market. Several landed in that 10 to 15% range. One came in over 20%. Only a handful landed under 3%. The Duramax XP13000 HXT one of the biggest tri-fuel models you can buy at around $2,500, has historically been listed at THD figures in the 10 to 12% range, though Duramax's current website claims under 5% for some units. So verify the spec sheet for the exact model you're buying. The Duramax XP15000 HXT is listed at under 12%, and the manufacturer's own documentation says it's unsuitable for sensitive electronics. The Westinghouse WGN10500 TFC comes in at under 23% THD. The Furman T08072 runs under 14%. And here's the part that should stop you cold. Westinghouse's own product page for that WGN10500 TFC claims it's under 23% THD output, allows you to safely power sensitive electronics like computers, phones, and televisions. That directly contradicts the safety threshold that electricians and equipment manufacturers actually use. The company selling you the generator and the engineers who build your electronics do not agree on what's safe. To put that in concrete terms, a 13,000-watt conventional tri-fuel generator running at 12% THD is delivering fundamentally dirtier power to your electronics than an 8,200-watt inverter running at 3% despite having fewer peak watts on paper. And it gets crazier. Wattage numbers appear in bold on every product page. Fuel types get colorful graphics and prominent placement. The THD specification, if it's listed at all, is buried in a PDF spec sheet or hidden on page 3 of the manual. One frustrated buyer posted online that after searching for tri-fuel models with THD below 5%, they simply couldn't find many. And eventually, I tracked down a Winco tri-fuel unit built on a Honda engine as one of the few clean options, priced well above the budget models everyone else was buying. So what actually happens when you plug sensitive electronics into a generator running 15 or 20% THD? Sometimes nothing. At first, that's the tricky part. Your laptop might charge fine for a week. Your furnace might fire up without complaint. Your CPAP might hum along like nothing's wrong. But high THD increases the risk of problems for sensitive electronics over time. Engineers call it phantom heat inside motors and power transformers, extra stress on power supplies working overtime to filter the noise, and gradual wear on insulation and control circuits. It does not mean every device connected to a conventional generator is doomed. Plenty of people run appliances on these units for years without issue. But the risk is real, uneven, and rarely disclosed. And when it does show up, it tends to show up weeks later, not the first night. Here's the reason this happens weeks later instead of immediately. The wear is cumulative. You will never trace it back to the generator because the failure did not happen the first night. But listen to this. One user on a power equipment forum shared exactly this experience. They bought a Westinghouse dual-fuel generator, ran a toaster fine, ran a hairdryer with no issues, then plugged in a microwave and it shut down after 5 seconds. When they called Westinghouse technical support, the technician said, quote, "Oh yes, that's a THD problem, 23%. Another user ran a 6,500-watt Coleman on a transfer switch during Hurricane Ian. It damaged 2 ceiling fans and one of their 2 refrigerators, and they never even turned on their televisions or computers. Their next generator, they said, would be an inverter. These aren't hypothetical risks. These are real people who ran into exactly what higher THD can do. Go back to everything we just listed. The medical equipment, the heating, ventilation, and air conditioning, the systems keeping your house running. That's the risk during a blackout. Not just an inconvenience if it fails, but a real problem at the worst possible time. It's worth noting that most of these conventional tri-fuel generators do include carbon monoxide sensors, CO Shield in the Champion lineup, CO Alert in the Duramax lineup, so the manufacturers are clearly thinking about one kind of safety. It's just not the kind your electronics need. So what's the solution? Inverter generators. They work fundamentally differently. Instead of producing AC power directly from engine rotation, they convert the raw output to DC, then use an inverter circuit to digitally reconstruct a clean sine wave. This keeps THD below 3%, regardless of engine speed, and the output is essentially indistinguishable from wall power. The problem is that until recently, tri-fuel and inverter technology rarely came in the same package. You had to choose between fuel flexibility and clean power. That's finally starting to change. The Champion 2011-76 is a tri-fuel inverter rated at under 3% THD with 9,000 peak watts. The Westinghouse iGen 8200 TFC delivers 8,200 peak watts at under 3% THD, and their larger iGen 11000 TFC hits 11,000 watts with that same clean output. These machines exist. They cost more, but they exist. If you have already bought a conventional tri-fuel generator, you are not entirely out of options. Placing a pure sine wave UPS between your generator and your sensitive devices can clean up the signal. A line interactive UPS will automatically switch to battery power if it detects total harmonic distortion above 5%. It is an added expense, but it is cheaper than replacing a furnace control board or a fried CPAP machine. What you should not rely on is a basic surge protector. A surge strip handles voltage spikes. It does nothing to clean up harmonic distortion. Nothing. The industry convinced everyone to compare generators by watts, but watts only tell you how much power you are getting. They do not tell you how clean that power is. And during a blackout, the most expensive thing connected to your generator probably is not the generator itself. It is everything inside your house.